Hello friends, in this video we are going to discuss about the boost converter, right? So it is also known as a step up chopper. Boost converter or step up chopper, right? Step up chopper. So here we are having a input supply is a DC, right? Next we are using a inductor, but be careful, this inductor is connected at the supply side. Okay, in the buck converter it was connected at the load side, now it is connected at the supply side, right? Here we are having the switch, or it is also known as the chopper. Here it is the diode D, the capacitor, in order to maintain the constant voltage across the load. And here we are having the load. Voltage across the load is V0, current flowing through the load is I0, current flowing through the capacitor is IC, current flowing through inductor is IL, voltage across inductor is VL, and source current is IS. Okay, so now here we are going to discuss first the circuit operation. Okay, so when switch is in the on state, right? So when switch is in the on state, so here we will be having the current will be flowing from source, that is a VDC, inductor, switch, and again back to the VDC. In this loop the current will be flowing. At the same time, yes, the capacitor discharges through the load, right? Capacitor go on discharging through the load, right? Means we will be having the two loops, we will be having the two loops. Okay, diode will be in the open circuit mode. Okay, so when switch is in the on state, when switch is in the on state, that is from t is equal to, from t is equal to 0 to t on, from t is equal to 0 to t on. Okay, so we'll be having the circuit like this: supply voltage, inductor, diode will be in the open circuit mode, right? Here it is a capacitor, and here it is a load, right? In the continuous conduction, yes, when switch is in the off state, at that time the capacitor charges, and when switch is in the on state, the capacitor go on discharging. Okay, and here switch is in the on state, right? This is the SW. Okay, diode, inductor, right? This voltage is VL, right? This current is IL. This is VDC, and here it is supply current IS. Okay, capacitor current is IC. This voltage is V0. This current is I0. Okay, so here if you check, yes, when switch is the on state, inductor go on storing the energy, right? So for the continuous conduction, inductor current go on increasing, inductor current go on increasing, right? Because inductor is storing the energy, right? Be careful, this is for continuous conduction only. Okay, next, so current in inductor current increases from Imin to Imax. Okay, next, at the same time capacitor is discharging, right? So here can we write IC is equal to minus I0, right? IC is equal to minus I0. So here we are having the IC, which is same method of the minus I0, right? Here we are assuming that the load current is constant and load voltage is also constant, right? So that's why here we have connected the capacitor in order to maintain the constant load voltage, right? So here load voltage and load current we are assuming the constant, right? So I0 is constant, so therefore what is IC? During 0 to t1, IC is equal to minus I0. So we can write IC is equal to minus I0. Okay, can we apply KVL to this loop? Yes, KVL to loop 1, KVL to loop 1, KVL to loop 1. Yes, if you check the KVL to the loop 1, we can write it as a plus VDC, right? Or you can write it as a VS also, no problem, minus VL, okay, is equal to 0, right? So this indicates VL is equal to VDC, right? VL is equal to VDC, right? This is during the t is equal to 0 to t on. Okay, next, from t on to capital T, that is when switch is in the off state, when switch is in the off state, then what will happen? Yes, this supply and inductor releases the energy, right? So inductor energy will be same in addition to that of the supply energy, right? And diode will be in the on state, so current will be flowing in the outer loop, and at the same time capacitor go on charging. Okay, so from t is equal to t on to capital T, from t is equal to t on to capital T, right? So if you check, when or from t is equal to t on to capital T, t on to capital T, yes, from t on to capital T, yes, we can write switch is in the off state. When switch is in the off state, yes, we will be having the circuit like this is a supply voltage VDC, right? Here it is the inductor. Next, diode will be in the on state, which is in the open state or the off state. Here we will be having a capacitor. Here it is a load, right? So yes, this is the equivalent circuit during T on to capital T, and during T on to capital T. Okay, so here the capacitor we are having. Here it is the diode. This is the inductor. Voltage across inductor is VL. Current flowing through the inductor is IL. Yes, this current is IS. Okay. Next current is IC. This current is I0. The voltage across load is V0. Okay. So now if you check during 0 to T on, what is IL? IL is same as that of IS. Okay, we can write here also. During 0 to T on, IL is equal to IS. Okay, IL and IS both are same. That is the source current and inductor current will be same. Okay, next from T on to T, yes, what is happening? The inductor is releasing the energy. Okay, so inductor releases the energy means what? Inductor current go on decreasing. That is current is changing from Imax to Imin. Okay, next, so Imax to Imin current is changing. Okay, so here for this circuit, can we apply KVL to the outer loop? Yes, we can write KVL to outer loop, KVL to outer loop. So we can write it as a plus VDC minus VL minus V0 is equal to 0. Okay, so therefore if you check, VL is equal to what? VDC minus V0. Okay, VDC minus V0, that is nothing but VL, that is nothing but the VL, right? Next, now can we apply KCL at this node, right? KCL at this node, so we can write it as a KCL here, right? So this is nothing but IL is equal to IC plus I0, right? So we can write IC is equal to what? IL minus I0, but I0 is a constant current. Okay, so it is like IL minus I0, we can write, right? IL minus I0. So if you check IL minus I0 waveform, yes, here I0 is this current. Okay, IL means at this instant it is at Imax minus I0, so it is a positive here. Okay, after that as IL decreases, IL minus I0 difference goes on decreasing. Okay, at this instant IL and I0 both will be same, right? So current will be 0, right? IC will be 0. After that IL is lesser than that of the I0, so that's why the difference IL minus I0, it will be negative. Okay, are you getting the point? Okay, so here IC is equal to IL minus I0. IC is equal to IL minus I0. Okay, so this is during T is equal to T on to capital T, right? T is equal to T on to capital T. Now, can we write the expression for Holt balance equation? Yes, we can write Holt balance equation. Yes, Holt balance equation. Holt balance equation, right? So in the buck converter, whatever the 14 parameters we have discussed, right? For the same parameters in the boost converter also, we are going to derive the expressions. Okay, so Holt balance equation. So voltage across inductor during T on plus voltage across inductor during T off is equal to 0, right? What is the voltage across inductor during the when switch is in the on state? If you check, yes, it is equal to VDC, right? This voltage is equal to VDC, so we can write it as VDC into dt. T on is a dt, right? So it is a VDC, right, into dt. Okay, VDC into dt plus what is the VL during T off? VL during T off is VDC minus V0, so it is a plus VDC minus V0 into T off, right? T off is T minus T on, but T on is dt, so it is a T minus dt, we can write is equal to 0. Okay, so further we can simplify it as, yes, we can write it as VDC into dt, yes, VDC into dt, right, plus VDC into T minus dt minus V0 into T minus dt is equal to 0. Okay, so therefore from this we can take VDC out common, so it is a VDC into, yes, it is a dt plus T minus dt, dt plus T minus dt. Are you getting the point? Okay, So it is a dt plus t minus dt minus v0 into what, t minus dt, right? So is equal to 0. Okay, so here dt dt will get cancel out. Okay, so we can write it as a vdc into t is equal to what, shift this v0 to the right hand side, so it is a v0 into t minus dt. Okay, so further we can write it as, therefore v0 is equal to what, t upon t minus dt, t upon t minus dt into vdc. Okay, so can we take the t common? Yes, from this, so we can write it as is equal to 1 upon 1 minus d, or t upon t into 1 minus d. Okay, are you getting the point? Into vdc, that is equal to v0. Okay, so therefore we can write tt will get cancelled. Okay, so here tt will get cancelled, and we can write it as, yes, t and t will get cancelled, so we can write it as v0 is equal to what, 1 upon 1 minus d into vdc. Okay, again vdc is the constant voltage. Okay, so this 1 upon 1 minus d, it will be some fraction or some value, it will be there, some integer will be there. Okay, so some that constant voltage into this integer, so this v0 will be your constant voltage, right? So we can write for that constant voltage, v0 is nothing but v0 average is equal to what, 1 upon 1 minus d. Okay, 1 upon 1 minus d, 1 upon 1 minus d into vdc. This is the expression for average load voltage, right? Average load voltage for boost converter, for boost converter. Are you getting the point? Okay, if you check, as duty cycle d is equal to what, t on by t, it is always less than 1. Okay, so if this value d is less than 1, right, so can we write it as 1 minus d, it will be, again this difference will be less than 1. Okay, so 1 by this less than 1 value is nothing but what, it is a greater than vdc. Okay, so therefore v0 average will be greater than vdc, means output voltage is greater than that of the input voltage. That's why it is known as the, yes, that's why it is known as the boost converter. That's why it is known as the boost converter. Are you getting the point, right? Is this clear? Okay, so this is about the some parameters expression, okay, related to the boost converter. In the next video we are going to discuss some additional parameters. Thank you.